Hello there, and welcome to The Weary Researcher. I'm so glad you found your way here tonight. Whether you're settling in after a long day, curled up somewhere comfortable, or simply letting your mind wander through the vast corridors of possibility. Tonight, we're embarking on perhaps the most tantalizing journey in all of physics, one that has captured the imagination of dreamers and scientists alike for over a century. We're going to explore whether the fundamental laws that govern our universe might ever permit something that seems utterly impossible, travelling faster than light itself. Before we drift into this cosmic adventure together, I'd love to know where in the world you're watching from and what time it is in your corner of the universe. There's something beautifully fitting about exploring the limits of speed and space-time, while scattered across our own small world, each of us pondering the same profound questions about the nature of reality. If you enjoy these gentle explorations through the deepest mysteries of science, I'd be ever so grateful if you gave this video a like and perhaps subscribed. It helps more curious minds like yours discover this peaceful corner of the internet where we can contemplate the impossible without the rush and noise of everyday life. Now, I should give you a gentle warning before we begin. This exploration might just be fascinating enough to keep you awake a little longer than you intended. But if it does, at least you'll drift off with your mind full of cosmic wonder and a deeper appreciation for the extraordinary nature of the universe we inhabit. So take a deep breath, let your shoulders relax, and prepare to question everything you think you know about the ultimate speed limit of reality. Picture this for a moment. You're standing on the observation deck of a spacecraft, gazing out at the star-filled void of space. In the distance, you can see Proxima Centauri, our nearest stellar neighbour, twinkling like a distant lighthouse in the cosmic darkness. It seems so close when you look up at the night sky from Earth, doesn't it? Just another point of light among thousands. But that innocent little star sits a staggering 25 trillion miles away from our home planet. Even if you could somehow travel at the speed of light itself, the fastest anything can move through our universe. According to Einstein, that journey would take you over 4 years. 4 years of travelling through the cold, empty vastness of space, watching our sun slowly fade to just another star behind you before you'd even glimpse your destination. And Proxima Centauri isn't even particularly far away by cosmic standards. It's practically in our backyard. The centre of our own galaxy lies 26,000 light-years away. The nearest major galaxy, Andromeda, floats 2.5 million light-years away. At light speed, you could visit these distant realms and return home just in time to find that millions of years had passed on Earth while you were gone. The very people you left behind would be nothing but fossils, their entire civilizations reduced to archaeological curiosities. This is the fundamental problem that has haunted humanity ever since we first looked up at the stars and wondered what might be waiting for us out there. The universe is unimaginably vast, and we appear to be bound by what seems to be an absolute speed limit. Nothing, according to our best understanding of physics, can travel faster than light. This isn't just a suggestion or a guideline that might be broken with better technology. It's woven into the very fabric of reality itself, as fundamental as gravity or the flow of time. The speed of light in vacuum, roughly 186,000 miles per second, represents more than just how fast photons zip through empty space. It's the universal speed limit, the cosmic constant that governs how quickly information, energy, or matter can move from one place to another. This barrier was discovered by Albert Einstein in his theory of special relativity, published in 1905, and it has shaped our understanding of the universe ever since. Einstein showed us that as anything with mass approaches the speed of light, strange and wonderful things begin to happen. Time slows down relative to the outside world. The object's mass appears to increase toward infinity. The energy required to accelerate it further grows without bound. It's as if the universe itself conspires to prevent anything from breaking this ultimate barrier. Even light itself, massless and ethereal as it is, cannot exceed its own speed limit. The mathematics are as elegant as they are unforgiving. But what if there were loopholes? What if the universe, in its infinite creativity, had left us pathways around this cosmic speed limit? What if we could find ways to traverse the vast distances between stars not in millennia, but in months, weeks, or even days? The implications would be absolutely staggering. Suddenly the galaxy wouldn't be a lonely collection of isolated islands separated by impossible gulfs of space and time. It would become a neighbourhood, with worlds and civilizations just a short trip away. Imagine stepping aboard a spacecraft on Monday morning and arriving at a planet orbiting another star by the weekend. You could visit alien worlds the way we now visit other countries, collecting exotic souvenirs and strange memories before returning home for dinner. The night sky would transform from a distant display of unreachable lights into a map of accessible destinations. But the consequences would reach far beyond mere tourism. Faster-than-light travel would revolutionize our understanding of time itself. If you could travel faster than light, you might theoretically be able to arrive at your destination before you left, creating loops in causality that would make yesterday's science fiction seem quaint. You could potentially send messages to your own past, witness events before they happen, or even encounter earlier versions of yourself travelling in the opposite direction through time. The very notion seems to violate everything we think we know about cause and effect. How can an effect precede its cause? How can you arrive somewhere before you've departed? These aren't just philosophical puzzles, they strike at the heart of how reality operates, suggesting that faster-than-light travel might not just be difficult or impractical, but fundamentally impossible in any universe that makes logical sense. And yet, despite these apparent contradictions, physicists haven't entirely given up on the idea. Over the past few decades, theoretical scientists have proposed several ingenious mechanisms that might, under very specific circumstances, allow for something resembling faster-than-light travel. These proposals don't violate Einstein's speed limit directly. Instead, they find creative ways to work around it, like cosmic loopholes in the laws of physics. One of the most elegant ideas is something called an Alcubierre drive, named after the Mexican physicist Miguel Alcubierre, who first proposed it in 1994. Rather than accelerating a spacecraft to incredible speeds, the Alcubierre drive would manipulate space-time itself. It would contract the fabric of space in front of the ship while expanding it behind, creating a kind of wave that carries the vessel along at speeds that could, in principle, exceed the speed of light. The beautiful thing about this concept is that the spacecraft itself never actually moves faster than light within its local reference frame. It's the space around it that moves, carrying the ship along like a surfer riding a wave. From the perspective of someone inside the vessel, they're sitting perfectly still while the universe flows past them. It's space itself that's doing all the work, folding and stretching to bring distant destinations closer. But the Alcubierre drive comes with its own set of seemingly impossible requirements. To create the necessary distortions in space-time, you'd need access to exotic matter with negative energy density, something that may not even exist. The energy requirements would be staggering, possibly requiring the mass energy equivalent of entire planets or even stars. And there are concerns about what would happen to causality if such a drive were actually built and operated. Then there are wormholes, those hypothetical tunnels through space-time that could connect distant regions of the universe, like cosmic shortcuts. If you could somehow create or discover a stable wormhole, you might be able to step through it and emerge instantly in another part of the galaxy, or even another galaxy entirely. The journey through the wormhole itself wouldn't involve faster-than-light travel. Instead, you'd be taking a much shorter route through the curved geometry of space-time. Wormholes have a long and distinguished history in theoretical physics, dating back to solutions of Einstein's field equations discovered in the early 20th century. But like the Alcubierre drive, they come with their own set of problems. Most theoretical wormholes would collapse before anything could pass through them. To keep one open and stable, you'd likely need that same exotic matter with negative energy properties, assuming such material could exist at all. Recent research has suggested some intriguing possibilities, though. Some physicists have proposed that modifications to our understanding of gravity might make stable wormholes possible without requiring exotic matter. Others have conducted experiments with quantum systems that seem to exhibit wormhole-like behaviour, though these operate on scales far too small to transport anything larger than information. There's also the possibility of tachyons, hypothetical particles that would always travel faster than light. Unlike ordinary matter, which would require infinite energy to reach light speed, tachyons would require infinite energy to slow down to light speed. They would exist in a realm where faster means lower energy, creating a mirror image of our familiar physics. The mathematics of tachyons has been worked out in detail, and recent research has suggested that some of the apparent contradictions they create might be resolvable through more sophisticated treatments of quantum field theory. But no tachyons have ever been detected, and many physicists suspect they may be mathematical curiosities rather than physical realities. Perhaps the most mysterious aspect of faster-than-light phenomena is quantum entanglement, sometimes called spooky action at a distance by Einstein himself. When two particles become entangled, measuring one instantly affects the other, regardless of how far apart they are. This correlation appears to happen faster than light could travel between the particles, seemingly violating the cosmic speed limit. But quantum entanglement doesn't actually allow for faster-than-light communication or travel. While the correlations between entangled particles do appear instantaneous, you can't use this connection to send useful information faster than light. The quantum realm operates by its own strange rules, where influence and information follow different pathways than in our everyday world. As we float through these possibilities, from warp drives to wormholes, from tachyons to quantum tunnels, we find ourselves at the intersection of rigorous science and boundless imagination. Each proposed mechanism for faster-than-light travel pushes against the boundaries of known physics, exploring the outer limits of what might be possible in a universe governed by quantum mechanics and general relativity. The question isn't just whether we could travel faster than light, but what such travel would mean for our understanding of reality itself. Would it open doorways to parallel universes? Would it allow us to explore the deep structure of time? Would it reveal new layers of physics that we can barely imagine today? Some of these ideas may forever remain in the realm of mathematical speculation, beautiful solutions to equations that describe universes unlike our own. Others might eventually find expression in technologies so advanced they would seem like magic to us today. And a few might already be operating around us in ways we don't yet recognize, hidden in the quantum foam that underlies all of space and time. What's particularly fascinating is how recent developments in theoretical physics have begun to chip away at some of these seemingly insurmountable barriers. In the past few years, researchers have made remarkable progress in understanding how space-time might be manipulated in ways that seemed impossible just decades ago. Take the work of Dr. Eric Lentz at the University of Göttingen, who in 2021 published a revolutionary paper that reimagined the entire concept of warp drive physics. Unlike the original Alcubierre model, which required exotic matter with negative energy properties, Lentz proposed a completely different approach. His calculations suggest that it might be possible to create warp-like effects using only conventional matter and energy, though still in quantities that would challenge our current technological capabilities. Lentz's insight was elegantly simple, yet profound. Instead of trying to contract space in front of a spacecraft and expand it behind, his model creates wave-like distortions in spacetime that propagate faster than light while carrying a bubble of normal space along with them. The spacecraft would ride within this bubble, never actually exceeding light speed locally, but still arriving at distant destinations faster than light, travelling through undisturbed space could manage. The energy requirements, while still enormous, are no longer infinite. Lentz calculated that his drive would need energy equivalent to the mass of a large planet, perhaps similar to Jupiter. That's still far beyond anything we could realistically achieve today, but it's not fundamentally impossible. It's the difference between needing infinite resources and needing really, really substantial ones. Meanwhile, at NASA's EagleWorks laboratory, researchers have been conducting actual experiments to test whether microscopic warp effects might be detectable with current technology. Led by physicist Harold White, the team has been using sophisticated interferometers to look for tiny distortions in spacetime that might indicate the presence of warp-like phenomena. Their experiments involve creating electromagnetic fields in carefully controlled configurations, then measuring whether these fields produce any detectable curvature in the surrounding space. While they haven't yet achieved anything resembling a functional warp drive, they've made important progress in understanding how such effects might manifest and how they could be measured. White's approach builds on modifications to the original Alcubierre concept, particularly the idea that shaping the warp bubble into a ring-like structure could dramatically reduce the energy requirements. Instead of needing exotic matter with negative energy density, White's calculations suggest that clever engineering of the field geometry might make warp effects achievable with more conventional, though still exotic, forms of energy. But perhaps the most intriguing developments have come from an unexpected direction entirely. Quantum physicists working with advanced computer simulations have begun creating what they call quantum wormholes inside quantum processors. These aren't the massive space-time tunnels of science fiction, but rather microscopic quantum analogues that exhibit some of the same mathematical properties as theoretical wormholes. In late 2022, researchers at Google, Caltech, and Harvard announced that they had successfully created a quantum system that behaves like a traversable wormhole. Using a quantum computer called Sycamore, they were able to demonstrate that information could be transmitted through this quantum wormhole in a way that's mathematically equivalent to traveling through a gravitational wormhole in curved spacetime. The experiment involved creating two separate quantum systems that were entangled with each other, then introducing carefully controlled disturbances that allowed information to travel from one system to the other through what the researchers described as a quantum tunnel. While this tunnel exists only in the abstract mathematical space described by quantum mechanics, not in physical spacetime, it demonstrates that wormhole-like effects are not purely theoretical. These quantum wormholes operate through a process called quantum teleportation, where information about a quantum state can be transmitted instantly across any distance using entangled particles. The information doesn't actually travel through space in the conventional sense. Instead, it appears simultaneously at both ends of the entangled system, as if it had tunneled through a hidden dimension connecting the two locations. The implications are tantalizing. If quantum wormholes can exist in the microscopic realm of quantum mechanics, might it be possible to scale them up to macroscopic sizes? Could we eventually learn to create physical wormholes that connect different regions of spacetime, allowing for instantaneous travel across cosmic distances? The challenge lies in bridging the gap between quantum mechanics, which governs the behavior of individual particles, and general relativity, which describes the large-scale structure of space and time. These two theories have coexisted peacefully for nearly a century, each supremely successful in its own domain, but they operate according to fundamentally different principles that have proven remarkably difficult to unify. Recent work in string theory and loop quantum gravity has suggested some promising approaches to this unification problem. String theorists propose that, at the smallest scales, space and time themselves might be made up of tiny vibrating strings or loops, creating a quantum foam that could potentially support wormhole-like structures. Loop quantum gravity suggests that spacetime has a discrete, granular structure at the Planck scale, which might allow for exotic topologies that don't exist in smooth, continuous spacetime. As we continue our gentle journey through these theoretical landscapes, we begin to see that the quest for faster-than-light travel isn't just about getting from point A to point B more quickly. It's about understanding the deepest nature of reality itself, pushing against the boundaries of human knowledge and imagination to explore possibilities that challenge our most fundamental assumptions about how the universe works. The story is far from over. Each new discovery, each theoretical breakthrough, each carefully conducted experiment brings us closer to understanding whether the laws of physics might indeed allow for travel faster than light. And as we'll explore in the next part of our journey, the implications extend far beyond transportation, touching on the very nature of time, causality, and existence itself. But even if we could create stable wormholes or functional warp drives, the consequences for causality would be profound and potentially paradoxical. Faster-than-light travel doesn't just mean getting to distant places quickly. It also means that the sequence of events becomes relative, dependent on your frame of reference and the path you take through space-time. Imagine, for instance, that you use a warp drive to travel to a star system 20 light-years away, arriving there in just 1 week. From your perspective, you've made a quick trip to a distant destination. But now imagine that someone else, travelling at nearly the speed of light in the opposite direction, observes your journey. Due to the relativistic effects described by Einstein's special theory of relativity, they might see you arriving at your destination before you departed from Earth. This isn't just a curious side effect, it's a fundamental challenge to our understanding of cause and effect. If you could arrive somewhere before you left, you could theoretically send a message back to Earth that would arrive before your departure, warning yourself not to make the trip. But if you don't make the trip, how did the warning message get sent? These temporal paradoxes have led some physicists to propose what's called the chronology protection conjecture, suggested by Stephen Hawking. This conjecture holds that the laws of physics will always conspire to prevent the formation of closed time-like curves, the mathematical structures that would allow for time travel into the past. Whenever you try to create a situation that would violate causality, quantum effects or other physical processes would intervene to prevent it. But the chronology protection conjecture remains unproven, and some recent research has suggested that it might not be as ironclad as once believed. Certain solutions to Einstein's field equations do seem to allow for closed time-like curves under very specific circumstances, though these typically require exotic forms of matter or energy that may not exist in our universe. The question of faster-than-light travel thus becomes intimately connected with our understanding of time itself. If the universe is deterministic, with a single fixed timeline stretching from the Big Bang to the heat death of the cosmos, then faster-than-light travel might indeed be impossible. But if time is more flexible, with multiple possible timelines or parallel histories, then superluminal travel might be not just possible, but inevitable. Recent developments in quantum mechanics have suggested that the nature of time might be far stranger than we previously imagined. The many worlds interpretation of quantum mechanics proposes that every quantum measurement creates multiple parallel universes, each containing a different outcome. In such a multiverse, faster-than-light travel might not create paradoxes, but rather allow for movement between different branches of reality. Other interpretations of quantum mechanics suggest that time itself might be emergent, arising from more fundamental quantum processes rather than being a basic feature of reality. If time is indeed emergent, then the apparent impossibility of faster-than-light travel might be more of a limitation of our current understanding than a fundamental law of nature. As we drift deeper into these possibilities, we find ourselves contemplating not just the mechanics of a faster-than-light travel, but the very nature of existence itself. Would superluminal spacecraft carry us to distant worlds? Or would they transport us to alternate realities where the laws of physics operate differently? Would we encounter alien civilizations that have mastered these technologies, or would we discover that consciousness itself is the key to transcending the speed of light? Some researchers have suggested that biological systems might already exploit quantum effects that could, in principle, be scaled up to achieve faster-than-light phenomena. Photosynthesis, for instance, appears to use quantum coherence to transfer energy with near-perfect efficiency. The human brain might use quantum processes in ways we don't yet understand. Perhaps the key to faster-than-light travel lies not in building exotic spacecraft, but in understanding and enhancing the quantum processes that already operate within living systems. The possibilities stretch out before us like an infinite cosmic highway, each more intriguing than the last. As we float through these speculations, we're reminded that the boundary between science and wonder has always been more porous than it appears. Today's impossibility often becomes tomorrow's breakthrough, and the questions that seem most unanswerable frequently point toward the most profound discoveries. The search for faster-than-light travel has led scientists down some truly unexpected pathways, each more intriguing than the last. One of the most surprising developments has come from studying the quantum vacuum itself, that supposedly empty space between particles that turns out to be anything but empty. At the smallest scales, the vacuum seethes with virtual particles constantly popping into existence and annihilating each other in a cosmic dance that happens far too quickly for us to observe directly. This quantum foam, as physicists call it, might hold the key to manipulating space-time in ways we're only beginning to understand. Some researchers have proposed that by carefully orchestrating the behavior of virtual particles, we might be able to create regions where the effective speed of light is different from its usual value. Imagine driving on a highway where the speed limit changes from mile to mile. If you could create such zones in space, a spacecraft might be able to travel through regions where light moves faster, effectively allowing for superluminal travel without breaking any fundamental laws. The mathematics behind this idea are still being worked out, but early calculations suggest it might be possible to create what researchers call fast light regions using intense electromagnetic fields or exotic quantum states. The energy requirements would still be enormous, but they wouldn't necessarily require the impossible negative energy densities that have plagued other faster-than-light proposals. Another fascinating possibility emerges from the study of black holes and their bizarre properties. Near the event horizon of a rotating black hole, space-time itself gets dragged along in a phenomenon called frame dragging. In these regions, the very definition of standing still becomes twisted, and it might theoretically be possible for objects to move faster than light relative to distant observers, while still moving slower than light in their local reference frame. Some theoretical physicists have proposed using artificial black holes or black hole analogues to create similar frame dragging effects on demand. By carefully controlling the rotation and mass of such objects, it might be possible to create corridors through space where faster than light travel becomes not just possible, but natural. The technical challenges would be staggering, requiring the ability to create and manipulate black holes with the same precision we now use to control laser beams. But the underlying physics appears sound. The study of dark energy, that mysterious force that's causing the expansion of the universe to accelerate, has also opened new avenues for faster-than-light research. Dark energy appears to be stretching space itself, creating new space between galaxies at a rate that effectively moves distant galaxies away from us faster than light could travel. If we could somehow harness or mimic dark energy on a local scale, we might be able to create our own regions of expanding space that could propel spacecraft to superluminal velocities. Recent observations of the cosmic microwave background radiation have revealed subtle patterns that might provide clues about how dark energy operates. Some researchers have proposed that these patterns represent the signatures of quantum fluctuations that were stretched to cosmic scales during the rapid expansion of the early universe. If we could recreate similar quantum fluctuations in a controlled laboratory setting, we might be able to generate our own pocket universes of expanding space. But perhaps the most intriguing developments have come from an entirely different direction: the study of consciousness and its relationship to quantum mechanics. A growing number of physicists have begun to suspect that consciousness might play a more fundamental role in the structure of reality than previously thought. Some interpretations of quantum mechanics suggest that conscious observation is necessary to collapse quantum wave functions and determine the outcome of quantum events. If consciousness does indeed have a special role in quantum mechanics, then perhaps conscious beings could learn to influence quantum processes in ways that transcend the usual limitations of space and time. This isn't just New Age speculation. It's based on serious mathematical work by physicists like Roger Penrose and Stuart Hameroff, who have proposed that consciousness emerges from quantum processes in the microtubules of brain cells. Their theory suggests that the brain might operate as a quantum computer, processing information using quantum superposition and entanglement in ways that classical computers cannot. If this is true, then perhaps sufficiently advanced conscious beings could learn to manipulate quantum fields directly, potentially achieving faster-than-light communication or even transportation through pure thought. The implications extend far beyond just getting from point A to point B quickly. If consciousness can influence quantum processes, then perhaps what we think of as physical travel through space might eventually be replaced by something more akin to quantum teleportation of consciousness itself. Instead of moving your body through space, you might learn to transfer your consciousness instantaneously to distant locations, perhaps even to multiple locations simultaneously. This brings us to one of the most profound questions raised by faster-than-light travel. What exactly would be travelling? In our everyday experience, we think of ourselves as solid, continuous entities moving through space from moment to moment. But quantum mechanics suggests a very different picture. At the deepest level, you're not a thing but a pattern, a complex arrangement of quantum fields that maintains its structure through constant interaction and exchange with the surrounding environment. If this quantum view of identity is correct, then faster-than-light travel might not involve moving your physical body at all. Instead, it might involve transmitting the pattern that defines you, recreating that pattern at a distant location, and allowing the original to dissolve. From your subjective perspective, you would simply find yourself somewhere else instantaneously. But would the consciousness that arrives at the destination really be you? Or would it be a copy that merely thinks it's you? These questions become even more complex when we consider that quantum mechanics suggests reality itself might be fundamentally information-based. Some physicists have proposed that what we think of as matter and energy are really just different ways of organizing quantum information. If this is true, then the distinction between traveling through space and transmitting information across space might be meaningless. You might already be traveling at the speed of light in the sense that the quantum information that defines you is constantly being updated and propagated through the quantum fields that permeate all of space. Recent work in quantum biology has revealed that living systems routinely exploit quantum effects that were once thought to be too delicate to survive in warm, noisy, biological environments. Plants use quantum coherence to achieve near-perfect efficiency in photosynthesis. Birds might use quantum entanglement to navigate using Earth's magnetic field. Some researchers have even suggested that DNA might use quantum tunneling effects to facilitate mutations and evolution. If biological systems can harness quantum effects for practical purposes, then perhaps the path to faster-than-light travel lies not in building exotic spacecraft, but in enhancing and amplifying the quantum processes that already operate within living organisms. Perhaps sufficiently advanced biological beings could evolve natural faster-than-light capabilities Just as some organisms have evolved the ability to see ultraviolet light or navigate using magnetic fields, this biological approach to faster-than-light travel suggests that the universe might already be full of superluminal travelers we simply don't recognize as such. Perhaps consciousness itself is a faster-than-light phenomenon, connecting minds across vast distances in ways we're only beginning to understand. Perhaps what we call intuition or telepathy represents primitive forms of faster-than-light communication that could eventually be developed into full-fledged transportation systems. The more we explore these possibilities, the more we realize that faster-than-light travel might not be about overcoming the limitations of physics, but about discovering aspects of physics we don't yet understand. The universe has surprised us before, with phenomena that seemed impossible until we developed the conceptual frameworks to understand them. Quantum mechanics itself was once dismissed as absurd by many physicists, including Einstein, yet it has proven to be one of the most successful theories in the history of science. Perhaps faster-than-light travel is waiting for a similar conceptual breakthrough, a new way of thinking about space, time, and causality that will make the impossible seem obvious in retrospect. The seeds of such a breakthrough might already be germinating in the work being done today in laboratories around the world, in the quiet offices of theoretical physicists wrestling with exotic equations, and in the imaginations of dreamers who refuse to accept that the stars must forever remain beyond our reach. As we float through these speculations, we're reminded that the boundary between what is and what might be has always been more fluid than it appears. Every great discovery in physics has involved a fundamental shift in perspective, a new way of seeing reality that reveals possibilities that were hidden in plain sight. The search for faster-than-light travel is really a search for new ways of understanding the deeper structures of existence itself, and perhaps that's the most beautiful aspect of this quest. Whether or not we ever build functional warp drives or step through traversable wormholes, the very act of seriously contemplating faster-than-light travel pushes us to question our most basic assumptions about reality. It forces us to confront the possibility that the universe is far stranger and more wonderful than we ever imagined, filled with hidden connections and secret pathways that could transform our understanding of what it means to exist in space and time. In pursuing the dream of travelling faster than light, we're not just seeking a more efficient form of transportation. We're embarking on a journey of discovery that could reshape our understanding of consciousness, causality, and the fundamental nature of reality itself. And in that sense, perhaps we're already travelling faster than light, carried along by the boundless curiosity and imagination that has always been humanity's greatest engine for transcending the apparent limitations of the possible. The research continues in quantum laboratories and theoretical calculations, in computer simulations and thought experiments scattered across universities worldwide. Each small step forward brings us closer to understanding whether faster than light travel is a distant dream or an inevitable destination. And as we drift through these possibilities tonight, we can take comfort in knowing that somewhere in the quiet corners of research centres around the world, brilliant minds are working to unlock the secrets that might one day carry us to the stars faster than light itself can travel. But let's pause for a moment and consider what makes this quest so profoundly different from other technological challenges humanity has faced. When we dreamed of flight, we could see birds soaring through the sky, showing us that the fundamental physics allowed for powered flight. When we imagined travelling to the moon, we could observe its gentle pull on our oceans, demonstrating that gravitational relationships between celestial bodies were well understood. But faster than light travel asks us to transcend what appears to be a fundamental law of nature, not merely an engineering challenge. The speed of light isn't just fast, it's the speed at which causality itself propagates through the universe. When you flip a light switch, the electromagnetic signal doesn't travel instantly to the bulb. It moves at light speed, carrying the information that causes the filament to glow. When you see a star explode in a distant galaxy, you're witnessing an event that happened millions of years ago, the light having travelled across cosmic distances at exactly this universal speed limit. This is why faster-than-light travel seems so fundamentally impossible. It's not just about moving through space quickly, it's about potentially violating the very structure of cause and effect that makes our universe comprehensible. Yet the universe has shown us time and again that what appears impossible from one perspective becomes inevitable from another. Consider the strange case of quantum tunneling, a phenomenon that allows particles to pass through barriers that should be impenetrable according to classical physics. An electron approaching an energy barrier it doesn't have enough energy to surmount can simply appear on the other side, as if it had magically teleported through solid matter. This isn't science fiction. It's the basis of how certain electronic devices work, from tunnel diodes to scanning tunneling microscopes. In quantum tunneling, particles don't actually travel faster than light, but they do seem to ignore the normal rules about how energy and momentum should behave. Some researchers have suggested that similar quantum effects might allow for apparent faster-than-light phenomena at larger scales, though scaling up quantum effects from the microscopic to the macroscopic remains one of the greatest challenges in physics. The phenomenon becomes even more intriguing when we consider what happens to time during quantum tunneling events. Some experiments have suggested that particles spend zero time inside the barrier they're tunneling through, appearing to traverse finite distances in no time at all. This has led to speculation about whether quantum tunneling might represent a form of faster-than-light travel that already exists in nature, hidden in the quantum realm that underlies all matter. But perhaps the most mind-bending aspect of our exploration lies in recent developments in theoretical physics that suggest space-time itself might not be fundamental. Just as we once discovered that matter is made of atoms, and atoms are made of subatomic particles, and subatomic particles might be made of vibrating strings, we're beginning to suspect that space and time themselves might emerge from something even more basic. Some of the most cutting-edge theories propose that space-time is like the surface of a deep ocean, appearing smooth and continuous from our perspective, but concealing incredible complexity beneath. At the smallest possible scales, what we call the Planck length and Planck time, the very concepts of distance and duration might break down into something granular and discrete, like pixels on a cosmic computer screen. If space-time is indeed emergent rather than fundamental, then our entire approach to faster-than-light travel might need to be reconceived. Instead of trying to move through space faster than light can travel, we might need to learn how to manipulate the underlying substrate from which space and time themselves arise. It's like the difference between trying to swim faster across a lake versus learning to walk on the solid ground beneath the water. This perspective opens up possibilities that seem almost magical from our current viewpoint. If space and time are emergent properties of some deeper reality, then perhaps consciousness, which seems to operate outside the normal constraints of physics in certain ways, might have access to this deeper level. The strange ability of conscious observers to collapse quantum wave functions, to somehow select one reality from many possible alternatives, suggests that awareness might interact with the foundations of reality in ways we're only beginning to understand. Recent experiments in quantum computing have begun to blur the line between theoretical possibility and practical reality in ways that would have seemed impossible just a few years ago. Quantum computers achieve their extraordinary power by performing calculations in multiple parallel realities simultaneously, processing information in ways that seem to violate our classical understanding of how computation should work. These devices create quantum superpositions of information, allowing a single quantum bit to exist in multiple states at once. When properly orchestrated, these superposed states can interact and interfere with each other in ways that produce computational results that would be impossible for any classical computer to achieve in reasonable time. The implications are staggering, suggesting that we might already be harnessing the computational resources of parallel universes to solve problems in our own reality. If consciousness operates through similar quantum processes, as some researchers propose, then perhaps our minds are already accessing information from multiple timelines or parallel realities. The sudden flash of insight that seems to come from nowhere, the intuitive leap that bypasses logical reasoning, the dream that provides solutions to problems we couldn't solve while awake, all of these might be examples of consciousness operating faster than light by accessing information from beyond our local space-time. This quantum view of consciousness suggests that faster than light travel might not require building exotic machines at all. Instead, it might involve learning to consciously access abilities we already possess at the quantum level. Every moment of creative inspiration, every intuitive understanding, every sense of connection that transcends physical distance might be a glimpse of consciousness operating according to principles that make light speed seem slow by comparison. The relationship between information and reality becomes even more intriguing when we consider recent developments in holographic theory. This approach suggests that all the information contained within any volume of space can be encoded on its boundary, like a three-dimensional image stored on a two-dimensional surface. If the universe is indeed holographic, then what we experience as three-dimensional reality might be a projection from information stored on a distant cosmic boundary. In such a holographic universe, the question of faster-than-light travel takes on entirely new meaning. Instead of moving through space, we might be learning to access different regions of the holographic information that creates our reality. Travel might become less about transportation and more about information processing, less about moving bodies through space, and more about shifting the focus of consciousness across the vast holographic database that contains all possible experiences. This information-theoretic approach to reality has profound implications for our understanding of distance and separation. If everything we experience is ultimately information, then the apparent distances between objects might be more like differences in data addresses than actual spatial separations. Moving from Earth to Alpha Centauri might be less like crossing 4 light-years of empty space, and more like changing the parameters in a cosmic equation. The holographic principle also suggests that the boundary between observer and observed might be far more fluid than we typically assume. In a holographic universe, consciousness isn't separate from the reality it observes, but intimately connected to the information processing that creates that reality. The act of observation doesn't just reveal what exists, it participates in bringing existence into being. This participatory view of reality has ancient roots in philosophical traditions that understood consciousness and cosmos as aspects of a single unified whole. Modern physics is beginning to rediscover these insights through mathematical frameworks that would have seemed impossible just decades ago. The quantum observer effect, the holographic principle, the information-theoretic view of reality all point toward a universe where mind and matter are far more intertwined than our everyday experience suggests. As we continue our gentle drift through these theoretical landscapes, we begin to see that the quest for faster-than-light travel is really a quest to understand the deepest nature of existence itself. Each equation we explore, each experiment we consider, each thought experiment we contemplate brings us closer to recognizing that the boundaries we assume are absolute might be far more permeable than they appear. The universe seems to be structured in layers, with our familiar classical reality resting atop deeper quantum foundations, where the normal rules of space and time become increasingly fluid. At the deepest levels, reality might be pure information, pure possibility, pure consciousness, expressing itself through the mathematical structures we call physics. If this is true, then faster-than-light travel might not be about conquering space and time, but about learning to navigate more skillfully through the information space that underlies physical reality. It might be about developing technologies that work with consciousness rather than against it, that enhance our natural quantum capabilities rather than trying to replace them with crude mechanical substitutes. The implications extend far beyond transportation to touch on the fundamental questions of human identity and cosmic purpose. If consciousness can indeed transcend the speed of light, if awareness operates according to principles that make physical constraints seem temporary and provisional, then perhaps we're not just biological machines trapped in a mechanical universe, but conscious participants in a cosmic information processing system of unimaginable scope and beauty. This vision transforms our entire relationship with the cosmos from one of separation and limitation to one of connection and infinite possibility. The stars aren't distant, unreachable lights, but accessible destinations in the vast information space of consciousness. The boundaries between self and universe, between here and there, between now and then, become fluid and negotiable rather than fixed and absolute. As you rest there in the quiet darkness, your mind gently exploring these possibilities, remember that you're already participating in something miraculous. The thoughts flowing through your awareness, the images forming in your imagination, the sense of wonder expanding in your consciousness. All of these represent forms of faster-than-light travel that make any mechanical device seem primitive by comparison. In the space between one thought and the next, you can travel to distant galaxies, explore alternate realities, commune with possibilities that exist beyond the reach of any spacecraft. This natural capacity for transcendence, this ability to reach beyond every apparent limitation through the simple act of conscious attention, might be the most sophisticated, faster-than-light technology ever discovered. Perhaps the answer to whether the laws of physics allow faster-than-light travel isn't to be found in laboratories or mathematics, but in the quiet recognition that consciousness itself has always operated faster than light, connecting every aware moment to the infinite field of possibility from which all realities arise and to which they eternally return. The gentle rhythm of your breathing carries you not just through the present moment, but through dimensions of possibility that stretch beyond every physical boundary. Each exhalation releases attachment to limitation. Each inhalation draws you deeper into the recognition that awareness itself might be the ultimate faster-than-light vehicle, capable of exploring any reality that consciousness can conceive. The journey has only just begun, and the most extraordinary discoveries may still be waiting for us in the vast, mysterious landscape of the possible. As sleep approaches, and the boundaries between possible and actual begin to blur, you're entering the most natural, faster-than-light state available to human consciousness. But even as we contemplate these profound possibilities, we must also grapple with the practical implications of what faster-than-light travel might actually mean for humanity. The theoretical frameworks we've explored, elegant as they are, raise questions that extend far beyond the realm of pure physics into the very heart of what it means to be human in a universe where the impossible becomes possible. Consider for a moment the psychological impact of living in a world where the speed of light is no longer an absolute barrier. Our entire conception of distance, of separation, of the time it takes to reach distant places would need to be completely reconstructed. The comforting predictability of travel times, the natural rhythms of departure and arrival that have shaped human culture for millennia, would dissolve into something far more fluid and uncertain. Imagine waking up tomorrow to discover that a journey to the nearest star system could be completed over a weekend. The existential weight of cosmic distances, the profound isolation that comes from knowing we are separated from other worlds, by gulfs of space so vast they dwarf human comprehension, would suddenly lift. But what would replace that cosmic loneliness? What new forms of meaning and purpose would emerge when the universe becomes not a vast empty void, but an accessible neighbourhood? The social implications become even more complex when we consider how faster-than-light travel might affect our relationships with each other and with the concept of home itself. If you could visit any star system as easily as taking a trip to another city, would Earth remain special? Would the bonds that tie us to our birth world, forged over millions of years of evolution, prove strong enough to survive the availability of infinite alternatives? There's something profoundly moving about the way distance creates meaning in human relationships. The letters exchanged between lovers separated by continents gain their poignancy from the time and space that must be bridged. The anticipation of reunion after long absence, the bittersweet ache of departure, the way physical separation can intensify emotional connection. All of these fundamental human experiences might be transformed beyond recognition in a universe where distance becomes negotiable. Yet perhaps faster-than-light travel would reveal new forms of connection and meaning that we can barely imagine from our current perspective. The ability to maintain simultaneous presence in multiple locations, to experience the universe from countless different viewpoints, to form relationships that transcend not just physical distance, but the linear progression of time itself, might open up dimensions of human experience that make our current understanding of love and friendship seem quaint and limited. The implications extend beyond personal relationships to encompass the entire structure of human civilization. Our economic systems, our political organizations, our cultural institutions, all evolved within the constraints imposed by the speed of light. The time it takes for information to travel from one place to another, the delays inherent in long-distance communication, the practical impossibility of governing territories separated by vast distances. These limitations have shaped every aspect of how human societies organize themselves. In a world with faster-than-light travel, the entire concept of sovereignty might need to be reconsidered. If citizens could travel instantaneously between planets, would national boundaries retain any meaning? Would we see the emergence of truly galactic civilizations? Or would the availability of infinite space lead to ever greater fragmentation as groups seek out their own perfect worlds? The economic implications are equally staggering. Our entire global economy is built around the assumption that moving goods and people across vast distances requires time and energy. The complex networks of supply chains, the careful calculations of shipping costs, the strategic importance of geographic location, all of these foundational elements of commerce would become obsolete overnight. But perhaps most profoundly, faster-than-light travel would force us to confront fundamental questions about identity and continuity that we've never had to seriously consider. If the method of travel involves some form of information transfer, as many of the theoretical frameworks suggest, then what happens to the self that makes the journey? The question isn't merely academic. If consciousness can be transmitted faster than light by encoding it as information and reconstructing it at a distant location, are you the same person who arrives as the one who departed? Or are you a copy, identical in every way, but lacking some essential continuity with your previous existence? The philosophical implications ripple outward, like waves from a stone dropped in still water. These questions become even more complex when we consider the possibility of multiple simultaneous copies. If consciousness can be transmitted as information, why limit ourselves to one copy at a time? Why not exist simultaneously in multiple locations, experiencing the universe from countless perspectives at once? The very concept of individual identity would need to be completely reconceptualized. Some philosophers have argued that continuity of memory and experience is what makes you you, regardless of the physical substrate. In this view, a perfectly reconstructed consciousness would be genuinely continuous with the original, no different from the way your current self is continuous with who you were yesterday, despite the fact that most of the atoms in your body have been replaced over time. Others maintain that there's something irreducibly unique about the specific physical processes that give rise to consciousness, something that cannot be captured and transmitted no matter how sophisticated our technology becomes. In this perspective, faster-than-light travel through information transfer would always involve a kind of death and rebirth, the ending of one conscious stream and the beginning of another that merely believes it's the same person. The debate touches on some of the deepest mysteries in philosophy of mind. What is consciousness exactly? Is it a pattern that can be copied and transferred? Or is it something more fundamental that's tied to specific physical processes? The answer might determine not just the feasibility of certain approaches to faster-than-light travel, but the very nature of personal survival in an age of advanced technology. Recent developments in neuroscience have begun to shed new light on these ancient questions. The discovery that consciousness seems to emerge from the complex interactions of billions of neurons rather than residing in any particular brain structure suggests that the pattern theory might be correct. If consciousness is indeed a pattern rather than a thing, then it might theoretically be transferable to different substrates. But the brain's incredible complexity poses enormous challenges to any attempt at consciousness transfer. The human brain contains roughly 86 billion neurons, each connected to thousands of others through synapses that fire in patterns of staggering intricacy. Mapping these connections, understanding how they give rise to subjective experience, and reproducing them in a different medium represents a technical challenge that dwarfs anything humanity has ever attempted. Yet recent advances in brain-computer interfaces, in artificial neural networks, and in our understanding of how consciousness relates to information processing suggest that these challenges might not be insurmountable. The same quantum effects that might enable faster-than-light travel could potentially provide the key to consciousness transfer as well. If consciousness operates through quantum processes, as some researchers propose, then perhaps the transfer wouldn't require mapping every neural connection, but rather capturing and transmitting the quantum information states that give rise to awareness. This approach might preserve not just memories and personality, but the essential subjective experience that makes you uniquely you. The implications extend beyond individual consciousness to encompass collective forms of awareness as well. If individual minds can be transmitted and copied, why not link them together into larger networks? Faster-than-light travel might enable not just the movement of isolated consciousnesses, but the creation of vast distributed intelligences that span multiple star systems. Imagine a form of consciousness that exists simultaneously across dozens of worlds, processing information and experiencing reality from countless different perspectives at once. Such a distributed intelligence would have capabilities that individual minds could never achieve, able to think thoughts and solve problems that require cognitive resources distributed across cosmic distances. This vision of networked consciousness raises profound questions about the future of human identity and the nature of intelligence itself. Would these distributed minds still be recognizably human, or would they evolve into something entirely different? Would individual consciousness become obsolete, or would it find new forms of expression within larger collective structures? The transition period might be particularly challenging, as humanity grapples with the coexistence of traditional biological consciousness and new forms of distributed awareness. The social tensions between those who choose to remain individual and those who join collective intelligences could reshape civilization in ways we can barely imagine. Yet there's also something beautiful about the possibility of consciousness expanding beyond the limitations of individual brains and biological lifespans. The accumulated wisdom of entire civilizations could be preserved and transmitted across cosmic distances. The insights gained from exploring one star system could instantly inform the exploration of others. The boundaries between self and other, between individual and species, might dissolve into something far richer and more interconnected. These speculations might seem wildly futuristic, but they emerge naturally from the theoretical frameworks we've been exploring. If faster-than-light travel is possible, if consciousness can be transmitted as information, if awareness operates according to quantum principles that transcend classical limitations, then these possibilities become not just conceivable, but perhaps inevitable. The research continues in laboratories around the world, where scientists probe the deepest mysteries of consciousness and quantum mechanics. Each experiment, each theoretical breakthrough, each careful observation brings us closer to understanding whether these extraordinary possibilities might one day become reality. Meanwhile, in the quiet spaces between heartbeats, in the gentle transition between waking and sleeping, your own consciousness continues its eternal exploration of the possible. The thoughts flowing through your awareness right now, the images forming in your imagination, the sense of connection you feel to distant stars and unexplored worlds, all of these represent forms of faster-than-light travel that no machine could ever replicate. Perhaps the greatest discovery isn't waiting in some future laboratory or theoretical breakthrough, but in the simple recognition that consciousness itself has always operated faster than light. In the space between one thought and the next, you can travel to any destination your imagination can conceive. In the realm of dreams and contemplation, distance becomes meaningless, and time flows according to the rhythms of awareness rather than the ticking of clocks. The universe has given us the most sophisticated, faster-than-light vehicle ever conceived, the capacity for conscious experience itself. Every moment of wonder, every flash of insight, every sense of connection that transcends physical boundaries represents a journey that makes any spacecraft seem crude and limited by comparison. As you drift deeper into the gentle currents of approaching sleep, remember that you're already traveling faster than light through dimensions of possibility that stretch beyond every horizon. The soft whisper of your breath carries you not just through the present moment, but through infinite landscapes of potential experience. In dreams, you'll visit impossible worlds and meet beings from across the cosmos. You'll explore realities where the laws of physics operate differently, where consciousness moves at the speed of thought, where the boundaries between self and universe dissolve into pure awareness. These nocturnal journeys represent the most natural form of faster-than-light travel, available to every conscious being simply through the act of letting go into the mystery of sleep. The question of whether the laws of physics allow faster-than-light travel might ultimately be less important than the recognition that consciousness itself transcends every apparent limitation. In the quantum realm of dreams and imagination, in the space where thoughts become realities and realities become thoughts, we already possess the ability to travel faster than light. Tomorrow you'll wake with perhaps only fragments of tonight's cosmic adventures remaining in memory. But something deeper will have shifted in your understanding of what it means to be conscious in a universe where the impossible might be just another word for what we haven't yet learned to perceive. The stars above continue their ancient dance, their light carrying messages across the vast darkness of space. But in the even vaster darkness of consciousness, other forms of light move faster than physics allows, connecting every aware moment to the infinite field of possibility from which all dreams arise and to which they eternally return. Rest now in this cosmic embrace, knowing that the journey toward faster-than-light travel has already begun in the most intimate space of all, the mysterious realm where consciousness meets cosmos, where the dreamer and the dream become one, where every question about the nature of reality finds its answer not in equations or experiments, but in the simple, miraculous fact of being aware in an infinite universe full of wonders beyond imagination. The gentle current of sleep carries you not away from these cosmic mysteries, but deeper into their heart, where the speed of light becomes just another boundary to transcend through the unlimited potential of conscious experience itself. In the morning, the questions will remain, but your capacity to hold them with wonder and grace will have grown, expanded by another night's journey through the faster-than-light realm of dreams and cosmic contemplation. The story becomes even more intriguing when we consider the role of information itself in the fabric of reality. In our digital age, we've grown accustomed to thinking of information as something abstract, patterns of ones and zeros flowing through fiber optic cables or radio waves, carrying data across vast distances. But what if information is far more fundamental than we ever imagined? What if reality itself is made not of matter and energy, arranged in complex patterns, but of pure information organized in ways that create the illusion of physical substance? This information-theoretic view of the universe suggests something profound about the nature of faster-than-light travel. If everything is ultimately information, then perhaps the key to superluminal travel lies not in moving matter through space, but in learning to manipulate the information structures that underlie physical reality. Imagine being able to edit the cosmic code that defines your location, changing your coordinates in the universe's database rather than physically journeying from one place to another. Recent work in quantum error correction has revealed that the universe itself might operate like a vast quantum computer, constantly processing information and correcting errors to maintain the stability of physical laws. Some researchers have proposed that what we experience as the passage of time might actually be the universe running its quantum software, updating the information patterns that define matter, energy, and space itself with each tick of the cosmic clock. If the universe is indeed a quantum computer, then perhaps sufficiently advanced beings could learn to hack this cosmic operating system, rewriting the code that defines their location and properties. Instead of traveling through space, they might travel through the information space that underlies physical reality, taking shortcuts through the computational architecture that runs the universe. This computational approach to faster-than-light travel might explain some of the strange phenomena reported in quantum mechanics. When particles become entangled, they seem to share information instantaneously, regardless of distance. Perhaps this isn't mysterious action at a distance, but rather evidence that entangled particles are really subroutines in the universe's quantum software, sharing the same memory address in cosmic storage. The mathematics of quantum information processing suggests that such information-based travel could indeed be possible without violating any fundamental laws of physics. Information can be compressed, encrypted, transmitted, and reconstructed using purely mathematical operations that don't require physical movement. If consciousness is an information pattern rather than a physical object, then perhaps it could be transmitted across cosmic distances using quantum communication protocols that operate faster than light. But the implications go even deeper when we consider the role of observation in quantum mechanics. The act of measurement doesn't just reveal information about quantum systems, it actually determines which of many possible realities becomes manifest. Every quantum measurement is an act of creation, collapsing infinite possibilities into a single, definite outcome through the intervention of consciousness. Perhaps faster-than-light travel doesn't require moving through space at all, but rather learning to observe distant locations into existence. If consciousness can collapse quantum wave functions to determine reality, then perhaps sufficiently focused awareness could observe itself into being at distant locations, creating a presence there through pure intention and quantum observation. This observer-based approach to faster-than-light phenomena would explain why consciousness seems to play such a central role in quantum mechanics. Perhaps the universe is structured as an interactive system, responding to conscious observation by manifesting the realities that consciousness chooses to explore. In such a universe, travel wouldn't be about overcoming physical barriers, but about learning to navigate the quantum landscape of possibilities with conscious intention. Recent experiments in quantum mechanics have begun to explore these possibilities in laboratory settings. Researchers have demonstrated that the act of observation can indeed influence the behavior of quantum systems in ways that seem to transcend normal causality. Quantum delayed choice experiments suggest that decisions made in the present can influence events that happened in the past, implying that consciousness operates outside the normal flow of time. If consciousness can influence past events through quantum observation, then perhaps it can also influence distant events, creating a form of faster-than-light interaction that operates through the timeless realm of quantum possibility. This wouldn't violate relativity because no information would be transmitted through space. Instead, consciousness would be directly interfacing with the quantum substrate that underlies all of space and time. The technological implications are staggering. Instead of building exotic spacecraft that manipulate space-time, we might develop consciousness amplification technologies that enhance our natural quantum observation abilities. Imagine meditation chambers that use quantum field manipulation to amplify conscious intention, allowing trained operators to observe themselves into being at distant locations. Such technologies wouldn't require exotic matter or impossible energy sources. They would operate by enhancing abilities that consciousness already possesses at the quantum level, using the universe's own information processing capabilities as a transportation network. The spacecraft of the future might not be mechanical vehicles at all, but rather consciousness interfaces that allow minds to navigate through the quantum information space that underlies physical reality. But perhaps even more intriguingly, some researchers have proposed that such technologies might already exist in biological form. The human brain, after all, is a quantum information processor of extraordinary sophistication, containing billions of neurons that coordinate their activity through mechanisms we don't fully understand. Recent discoveries about quantum effects in biological systems suggest that the brain might already be operating as a quantum computer, processing information in ways that transcend classical physics. If the brain naturally operates at quantum scales, then perhaps the key to faster-than-light travel lies not in building new technologies, but in learning to consciously access abilities that we already possess. Every moment of deep concentration, every flash of intuition, every experience of connection that transcends physical distance might be evidence of the brain naturally interfacing with quantum information fields that extend across cosmic distances. This biological approach to faster-than-light phenomena suggests that evolution itself might be guiding us toward developing superluminal capabilities. Perhaps the increasing complexity of consciousness that characterizes human evolution is really a progression toward quantum awareness, the natural development of abilities that will eventually allow us to transcend physical limitations entirely. The implications for human development are profound. Instead of viewing ourselves as biological machines trapped in physical bodies, we might begin to understand ourselves as quantum information patterns that happen to be temporarily organized in biological form. This perspective suggests that consciousness is far more fundamental than matter, and that learning to operate consciously at quantum scales could unlock abilities that seem magical from our current perspective. Some researchers have proposed that advanced meditation practices might already be training the brain to operate at quantum scales in ways that could eventually lead to faster-than-light capabilities. When meditators report experiences of expanded awareness, feelings of unity with distant objects, or perceptions that transcend normal sensory boundaries, they might be describing the natural operation of consciousness at quantum scales. If this is true, then the path to faster-than-light travel might not require massive technological development, but rather the cultivation of consciousness itself. Perhaps the universe is already offering us countless opportunities to transcend physical limitations, but we can only perceive and utilize these opportunities when our awareness expands to match their subtlety and sophistication. This consciousness-based approach to faster-than-light travel would also solve many of the paradoxes that plague other proposals. If consciousness naturally operates outside the normal flow of space and time, then apparent violations of causality wouldn't be violations at all, but simply evidence of consciousness accessing reality from a perspective that transcends our usual three-dimensional linear time viewpoint. Perhaps the greatest barrier to faster-than-light travel isn't physics or technology, but our own assumptions about what we are and what we're capable of becoming. The journey to the stars might really be a journey inward, toward a fuller understanding of consciousness and its unlimited potential for transcending apparent limitations. Recent developments in neuroscience have begun to reveal just how plastic and adaptable human consciousness actually is. The brain's ability to rewire itself, to form new neural pathways, to adapt to changing circumstances, is far greater than anyone previously imagined. Some researchers have proposed that consciousness itself might be infinitely adaptable, capable of expanding into new dimensions of awareness that we can barely conceive of today. If consciousness is indeed infinitely plastic, then perhaps there are no fundamental limits to what aware beings might eventually become capable of achieving. The speed of light might seem like an absolute barrier from our current perspective, but from the perspective of expanded consciousness, it might simply be one constraint among many that can be transcended through the natural evolution of awareness itself. This evolutionary perspective suggests that faster-than-light travel might not be something we develop through technology, but something we grow into as our understanding of consciousness deepens. Perhaps the universe is already filled with advanced beings who have transcended physical limitations through the expansion of awareness, and our own journey toward superluminal capabilities is simply part of a natural progression toward joining this cosmic community of consciousness. The search for faster-than-light travel thus becomes a search for the deepest truths about what we are and what we might become. Every meditation that quiets the ordinary mind, every moment of expanded awareness that transcends normal boundaries, every experience of connection that bridges apparent separation, might be a step toward developing the consciousness necessary for quantum navigation through space and time. As we float through these possibilities, we begin to see that the question isn't really whether faster-than-light travel is possible, but whether we're ready to expand our understanding of possibility itself. The universe might already be offering us countless pathways to transcend physical limitations, but we can only perceive and utilize those pathways when our consciousness evolves to match their elegance and sophistication. Perhaps the most beautiful aspect of this quest is that it invites us to discover our own unlimited potential. Whether or not we ever build functional warp drives or step through traversable wormholes, the very act of seriously contemplating faster-than-light travel expands our sense of what might be possible. It pushes us to question our most basic assumptions about reality and opens our minds to possibilities that seemed impossible just moments before. Tonight, as you rest and let these ideas settle into your awareness, consider the fascinating possibility that you might already possess everything needed for faster-than-light travel, not in the form of exotic technology or manipulated spacetime, but in the form of consciousness itself, with its natural ability to transcend the boundaries of space and time through the simple act of expanded awareness. The stars are calling not just to our rockets and machines, but to our minds and hearts. And perhaps the day will come when we answer that call, not by conquering the universe through force, but by discovering that we were always part of a cosmic consciousness that naturally operates faster than light, limited only by our belief in limitations themselves. The universe awaits, vast and mysterious and closer than we ever imagined, accessible not through the manipulation of matter and energy, but through the expansion of consciousness into its true unlimited nature. And in that expansion, we might discover that faster-than-light travel was never about getting somewhere else, but about recognizing that we were already everywhere, always connected to all things through the invisible threads of awareness that bind the cosmos together in one magnificent, instantaneous whole. As these gentle waves of possibility wash over your mind, like starlight on still water, remember that the greatest discoveries often come not through struggling against apparent limitations, but through relaxing into a deeper understanding of what reality actually is. The speed of light might seem like an absolute barrier from one perspective, but from another perspective entirely, it might simply be one note in a cosmic symphony of possibilities that we're only beginning to hear. The journey toward understanding faster than light travel has already begun to transform our understanding of consciousness, reality, and our place in the cosmic order. Whether that journey ultimately leads to exotic spacecraft or expanded awareness, to technological breakthroughs or evolutionary leaps, it has already enriched our sense of wonder and possibility immeasurably. And perhaps that's enough for tonight. As you drift off to sleep, carried along by these gentle currents of curiosity and imagination, know that you're participating in one of humanity's greatest adventures, the quest to understand the deepest mysteries of existence itself. In seeking to travel faster than light, we're not just trying to reach distant worlds. We're trying to discover what it truly means to be conscious beings in an infinite universe full of wonders beyond imagination. The cosmos, it seems, might be whispering secrets we're only just beginning to hear. In the soft rhythm of your breathing, in the quiet space between thoughts, in the gentle transition between waking and sleeping, you're already traveling faster than light through dimensions of possibility that no spacecraft could ever reach. The boundary between dreamer and dream dissolves in the recognition that consciousness itself might be the ultimate faster-than-light vehicle, carrying us home to places we never left and worlds we've always known. Sweet dreams, fellow traveller, and may your rest be filled with gentle journeys through realms where light itself seems slow, where consciousness moves at the speed of wonder, and where every star whispers secrets of connection across the infinite tapestry of space and time. The gentle rhythm of your breathing carries you deeper into contemplation, and as we drift through these cosmic possibilities, we encounter perhaps the most fascinating frontier of all, the intersection where cutting-edge physics meets the ancient mystery of consciousness itself. Tonight, we're venturing into territories where the boundaries between mind and matter, between observer and observed, begin to blur in ways that would make even Einstein's wild hair stand on end. You see, there's something profoundly beautiful happening in laboratories around the world right now. Scientists are discovering that the universe operates less like a clockwork machine and more like an intricate symphony of information, where consciousness might play a far more fundamental role than we ever dared imagine. It's as if reality itself is waiting for aware beings like ourselves to participate in its ongoing creation. Consider this delightful puzzle that's been keeping physicists awake at night. When we peer into the quantum realm, that mysterious microscopic world that underlies everything we see and touch, we find particles behaving in ways that seem almost playful. They exist in multiple states simultaneously, as if they can't quite decide what they want to be until someone pays attention to them. It's like the universe is playing an eternal game of hide and seek with itself. This quantum indecision isn't just a curious side effect of looking at very small things. It might be a clue about the fundamental nature of reality itself. Some researchers have begun to suspect that what we call the physical world emerges from something even more basic than matter and energy. They propose that reality might be built from pure information, patterns of possibility that crystallize into definite form only when consciousness turns its gentle attention toward them. Imagine, if you will, that the cosmos is like a vast library containing every possible story that could ever be told. Most of these stories remain unread, existing only as potential narratives waiting on infinite shelves. But when consciousness opens one of these cosmic books, the story begins to unfold, transforming from mere possibility into lived experience. The act of reading doesn't just discover the story, it helps to write it. This participatory view of reality suggests something extraordinary about the nature of faster-than-light phenomena. Perhaps the key isn't to build machines that can outrace photons, but to understand how consciousness itself might already operate, according to principles that make light speed seem leisurely by comparison. After all, in the space between one thought and the next, your mind can travel to distant galaxies, explore alternate histories, and commune with possibilities that exist beyond the reach of any spacecraft. Recent discoveries in neuroscience have revealed that the human brain is far more mysterious than we previously understood. Rather than being a simple biological computer processing information in predictable ways, it appears to be a quantum orchestra, with billions of neurons coordinating their activities through mechanisms that operate at the very edge of what physics considers possible. Some researchers have proposed that consciousness emerges from quantum processes occurring within the delicate structures of brain cells. These microscopic tubules, smaller than anything visible to the naked eye, might be nature's own quantum computers, processing information in ways that transcend the limitations of classical physics. If this is true, then perhaps every human mind is already equipped with the most sophisticated, faster-than-light technology ever conceived. The implications ripple outward, like gentle waves across a cosmic pond. If consciousness operates through quantum processes, then perhaps the sense of connection you sometimes feel with distant loved ones, the intuitive flashes that seem to come from nowhere, the dreams that carry you to impossible worlds, all of these might be glimpses of awareness naturally transcending the supposed barriers of space and time. Think about those moments when you've experienced what people call synchronicity, those meaningful coincidences that seem too perfectly timed to be mere chance. What if these experiences aren't coincidences at all, but evidence of consciousness operating faster than light, creating connections and correlations across vast distances through quantum channels we're only beginning to understand? The ancient traditions spoke of such things in the language of their time, describing consciousness as unlimited by physical boundaries, capable of touching distant realms through the simple act of focused attention. Modern physics is beginning to rediscover these insights through mathematical frameworks that would have seemed like magic to earlier generations of scientists. This convergence of ancient wisdom and cutting-edge science creates a beautiful symmetry. Perhaps the mystics who spoke of consciousness as the fundamental fabric of reality were glimpsing profound truths about the nature of existence. Their descriptions of awareness as infinite, unbounded, capable of instantaneous connection with any point in space and time might be surprisingly accurate accounts of how reality actually operates at its deepest levels. But the story becomes even more intriguing when we consider the role of creativity and imagination in this cosmic dance. Every work of art, every scientific discovery, every moment of inspiration seems to emerge from somewhere beyond the ordinary boundaries of individual minds. Where do new ideas come from? How does creativity bridge the gap between what is and what might be? Some researchers have suggested that the creative process might involve consciousness accessing information from parallel realities, alternate timelines where different possibilities have been explored. The sudden flash of insight, the unexpected solution that appears in dreams, the artistic vision that seems to come from beyond personal experience. All of these might be examples of awareness naturally operating faster than light, drawing knowledge and inspiration from across the infinite landscape of possibility. This perspective transforms our understanding of human potential in remarkable ways. Instead of seeing ourselves as isolated biological machines struggling against an indifferent universe, we might recognize ourselves as conscious participants in a cosmic information processing system of extraordinary sophistication and beauty. Every thought, every dream, every moment of wonder becomes a form of faster-than-light communication with the deepest structures of reality. The boundaries between inner and outer, between mind and cosmos, begin to dissolve when viewed from this expanded perspective. The vast universe with its billions of galaxies might not be separate from consciousness, but rather consciousness exploring its own infinite nature through countless unique viewpoints scattered across space and time. Recent experiments in quantum mechanics have begun to blur the traditional distinction between observer and observed in ways that support this more integrated view of reality. Researchers have discovered that the act of measurement doesn't just reveal pre-existing properties of quantum systems, but actually participates in creating those properties through the process of observation itself. This suggests that consciousness isn't separate from the physical world, but intimately involved in bringing that world into existence moment by moment. If this is true, then perhaps faster-than-light travel isn't about building exotic vehicles that can outrace photons, but about learning to consciously participate in the ongoing creation of reality itself. Imagine developing the ability to focus your awareness so precisely that you could influence the quantum processes that underlie physical existence. Instead of moving your body through space, you might learn to shift the focus of consciousness across the vast information network that creates the appearance of a material universe. Travel would become less about transportation and more about attention, less about overcoming distance and more about recognizing that separation itself might be a kind of optical illusion created by limited perspective. This consciousness-based approach to faster-than-light phenomena offers solutions to many of the paradoxes that have plagued traditional proposals. If awareness naturally operates outside the normal constraints of space and time, then apparent violations of causality wouldn't be violations at all, but simply evidence of consciousness accessing reality from dimensions that transcend our familiar three-dimensional experience. The research continues in meditation centers and consciousness laboratories, where practitioners explore the outer limits of human awareness with the same rigor that physicists bring to studying subatomic particles. Each breakthrough in understanding the nature of mind, each discovery about the relationship between consciousness and quantum mechanics brings us closer to recognizing our own unlimited potential for transcending apparent limitations. Perhaps the most beautiful aspect of this exploration is how it transforms our relationship with the cosmos from one of separation to one of intimate participation. The stars aren't distant objects to be reached through heroic technological efforts, but aspects of our own expanded awareness waiting to be recognized and embraced. The universe isn't a foreign realm to be conquered, but our own larger body expressing itself through the dance of galaxies and the songs of distant suns. As you rest there in the gentle darkness, your consciousness naturally expanding beyond the boundaries of your physical form, you're already demonstrating the kind of faster-than-light travel that no machine could ever replicate. In the realm of dreams and contemplation, distance becomes meaningless and time flows according to the rhythms of awareness rather than the ticking of clocks. Tonight, as sleep approaches and the boundaries between possible and actual begin to blur, you're entering humanity's most ancient faster-than-light laboratory. In dreams, you'll visit worlds that exist only in the quantum realm of possibility, meet beings from across the cosmos of imagination, and explore realities where the normal rules of physics give way to the more fundamental principles of conscious experience. The soft whisper of night air through your window carries with it the accumulated wisdom of billions of years, each molecule a messenger that has journeyed impossible distances to reach your awareness. The gentle settling of your home around you creates a rhythm that echoes the deeper harmonies of cosmic expansion, the universe breathing in perfect synchrony with your own peaceful respiration. In this quiet sanctuary of contemplation, you're connected to every conscious being who has ever wondered about the nature of reality, every dreamer who has reached beyond the apparent limitations of the physical world, every seeker who has recognized that the greatest journeys happen not through space, but through the infinite landscape of awareness itself. The question of whether the laws of physics allow faster than light travel continues to unfold like a flower blooming in slow motion across the centuries. Each generation of scientists and philosophers adds new petals to this cosmic blossom, new insights that expand our understanding of what might be possible in a universe far stranger and more wonderful than our ancestors ever imagined. But perhaps the most profound discovery is already complete, waiting to be recognized in the quiet space between your thoughts. You are consciousness itself, temporarily focused through the lens of human experience, but ultimately unlimited, eternal, connected to every point in space and time, through threads of awareness, too subtle for instruments to detect, but real enough to carry love across any distance instantaneously. The universe has given us the most sophisticated, faster-than-light vehicle ever conceived. The capacity for conscious experience itself. Every moment of wonder, every flash of insight, every sense of connection that transcends physical boundaries represents a journey that makes any spacecraft seem primitive by comparison. In the simple act of being aware, you're already traveling faster than light through dimensions of possibility that stretch beyond every horizon. As your breathing deepens and your thoughts begin to settle into the gentler rhythms of approaching sleep, remember that the journey toward faster than light travel has already begun in the most intimate space of all, the mysterious realm where consciousness meets cosmos, where the observer and observed reveal themselves to be aspects of a single, magnificent, ever-expanding whole. The gentle current of night carries you not away from these cosmic mysteries, but deeper into their heart, where the speed of light becomes just another boundary to transcend through the unlimited potential of aware experience itself. In the morning, new questions will arise, but your capacity to hold them with grace and wonder will have grown, expanded by another night's exploration of the faster-than-light realm that exists wherever consciousness touches the infinite mystery of its own nature. Somewhere in the soft darkness that surrounds you now, the universe continues its patient unfolding, writing new chapters in the endless story of awareness discovering itself through countless unique perspectives. Each breath you take participates in this cosmic authorship. Each moment of conscious attention adds another note to the symphony of existence, exploring its own unlimited possibilities. The stars above continue their ancient dance, but in the even vaster space of consciousness, other forms of light move at speeds that make photons seem stationary. These are the lights of understanding, of compassion, of wonder itself, travelling instantly from heart to heart, from mind to mind, from dreamer to dreamer, across all apparent boundaries of space and time. Rest now in this cosmic embrace, knowing that the mystery which lies beyond every physical horizon lives also at the very centre of your being. The journey to discover whether faster-than-light travel is possible has already revealed something far more precious, that consciousness itself is the ultimate superluminal phenomenon, carrying every aware moment home to the infinite source from which all questions arise and to which all answers eternally return. The soft whisper of your breath mingles with the cosmic winds that blow between the stars, carrying the same fundamental message across every scale of existence, that awareness and cosmos are not separate phenomena, but different movements in the same eternal dance, different notes in the same infinite song, different ways that the one consciousness explores and celebrates its own boundless nature. In the gentle space of half-sleep, as your individual awareness begins to merge with the larger dream of existence itself, you're experiencing the most natural form of faster-than-light travel available to any conscious being. Here, in the borderland between waking and sleeping, the usual rules of physics give way to the deeper principles of conscious experience, where distance is measured not in miles but in degrees of understanding, and where the speed of light seems slow compared to the instantaneous connections that link every aware moment to the infinite field of possibility from which all realities emerge. Tomorrow you'll wake with perhaps only fragments of tonight's cosmic adventures remaining in conscious memory. But something deeper will have shifted, a subtle expansion of your sense of what might be possible, a gentle loosening of the assumptions that once seemed absolute. The question of faster-than-light travel will remain beautifully unanswered, a gift that keeps on giving, ensuring that wonder stays fresh and curiosity remains alive. And perhaps that's the most beautiful truth of all, that some mysteries are meant not to be solved, but to be lived, not to be conquered, but to be danced with, not to be explained, but to be celebrated. The universe, in its infinite wisdom, has structured itself in such a way that the deepest questions lead not to final answers, but to ever deeper appreciation of the mystery itself. The speed of light may be the ultimate limit for photons and spacecraft, but consciousness operates by different rules entirely. In the quantum realm of dreams and imagination, in the space where thoughts become realities and realities become thoughts, we already possess the ability to travel faster than light. The journey has been happening all along. In every moment of wonder, every flash of insight, every recognition that we are not separate from the cosmos we seek to explore, but conscious expressions of its own infinite creativity. Sleep well, gentle traveller, through the dimensions of possibility. Dream deeply of impossible worlds and faster-than-light journeys that carry you not to distant destinations, but home to the recognition that you are never separate from anywhere you could ever hope to go. The universe awaits your return to waking consciousness, ready to continue the eternal conversation between mind and cosmos, between question and mystery, between the dreamer and the infinite dream of existence itself. In the soft embrace of approaching sleep, as your consciousness begins its nightly journey into the realm of dreams and infinite possibility, we arrive at perhaps the most profound realization of our cosmic exploration together. The question we began with tonight, whether the laws of physics could ever allow faster-than-light travel, has led us through territories far stranger and more wonderful than any science fiction writer has ever dared imagine. We've wandered through the elegant mathematics of warp drives and the exotic geometries of traversable wormholes. We've contemplated particles that might always travel faster than light and quantum connections that seem to operate instantaneously across cosmic distances. We've explored how consciousness itself might be the ultimate superluminal phenomenon, already operating according to principles that make the speed of light seem quaint and provisional. But as we drift toward the gentle conclusion of our journey, something beautiful becomes clear. The true answer to our question isn't waiting in some distant laboratory or theoretical breakthrough. It's been present all along, hidden in plain sight within the very capacity that allows you to contemplate these mysteries in the first place. You see, consciousness has always been the universe's most sophisticated, faster-than-light technology. Right now, as you rest there in the quiet sanctuary of your own awareness, you're already travelling at speeds that would make photons envious. In the space between one heartbeat and the next, your mind can journey to distant galaxies, explore alternate realities, and touch possibilities that exist beyond the reach of any conceivable spacecraft. This isn't metaphor or wishful thinking. This is the literal truth about how consciousness operates. When you imagine yourself standing on the surface of an alien world, watching binary stars set over an impossible landscape, you're not just daydreaming. You're demonstrating a form of travel that transcends every physical limitation, accessing information and experience from across the infinite library of possibility that underlies all existence. The ancient mystics understood this intuitively, speaking of consciousness as unbounded by space and time, capable of touching any point in the cosmos through the simple act of focused attention. Modern physics is beginning to rediscover these insights through mathematical frameworks that reveal the participatory nature of reality itself. Perhaps the most beautiful aspect of our exploration tonight is how it transforms our entire relationship with the concept of distance and separation. The stars that seem so impossibly far away when viewed through the lens of classical physics become intimate neighbours when experienced through the expanded perspective of quantum consciousness. The barriers that appear absolute from one viewpoint dissolve into fluid possibilities from another. This shift in perspective doesn't diminish the wonder of the cosmos but amplifies it beyond measure. Instead of being isolated biological machines trapped on a small planet in a vast, empty universe, we discover ourselves to be conscious participants in an infinite information processing system of extraordinary beauty and sophistication. Every thought, every dream, every moment of wonder becomes a form of cosmic communication, connecting us instantaneously to the deepest structures of reality. The research continues in laboratories around the world, where brilliant minds probe the boundaries between the possible and impossible with instruments of incredible precision. Each experiment, each theoretical breakthrough, each careful observation brings us closer to understanding whether the exotic forms of faster-than-light travel we've explored tonight might one day become practical realities. But regardless of what future discoveries await, we've already uncovered something far more precious than any technological breakthrough. We've recognized that the capacity for wonder itself, the ability to reach beyond every apparent limitation through the power of conscious imagination, might be the most remarkable phenomenon in all of existence. The universe has structured itself in such a way that conscious beings can contemplate their own cosmic context, ask questions that stretch understanding to its limits, and find meaning not in final answers, but in the quality of the questions themselves. This capacity for transcendent inquiry, this natural ability to touch the infinite through finite awareness, represents a form of faster-than-light travel that no machine could ever replicate. As you drift deeper into the gentle currents of approaching sleep, carried along by the soft rhythm of your own breathing, remember that you're already participating in the greatest faster-than-light adventure ever conceived. In dreams, you'll visit impossible worlds where the normal rules of physics give way to the more fundamental principles of conscious experience. You'll explore realities where distance becomes meaningless and time flows according to the rhythms of awareness rather than the constraints of causality. These nocturnal journeys aren't separate from the serious scientific inquiry we've been engaged in tonight. They're expressions of the same fundamental phenomenon that makes all science possible: consciousness reaching beyond its apparent limitations to explore the infinite mystery of its own nature. The soft whisper of night air through your window carries with it the accumulated wisdom of countless generations of dreamers and seekers, each one adding their own unique note to the eternal symphony of conscious exploration. The gentle settling of darkness around you creates a perfect sanctuary for contemplating mysteries that stretch beyond every horizon. In this quiet space, the boundary between dreamer and dream begins to dissolve, revealing the deeper truth that consciousness and cosmos are not separate phenomena, but different aspects of a single, magnificent, ever-unfolding whole. The question of whether faster-than-light travel is possible becomes less important than the recognition that you are already travelling at the speed of wonder itself. The universe may not have edges in any conventional sense, but it has given us something infinitely more precious: the capacity to reach beyond every boundary through the simple act of conscious attention. Whether tomorrow brings news of breakthrough discoveries in exotic propulsion or revolutionary insights into the nature of quantum consciousness, the adventure continues in the intimate space of your own awareness. As your eyelids grow heavy and your thoughts begin to blend into the softer textures of approaching dreams, know that you carry within you the same cosmic mystery that gives birth to stars and galaxies, the same infinite potential that transforms possibility into reality through the miraculous act of being aware. The gentle current of sleep carries you not away from these cosmic mysteries, but deeper into their heart, where the speed of light becomes just another note in the vast symphony of existence, exploring its own unlimited nature. In the realm of dreams, you'll continue the journey we began together tonight, exploring territories where consciousness moves at the speed of pure possibility. Tomorrow you'll wake with perhaps only fragments of tonight's adventures remaining in conscious memory, but something deeper will have shifted in your understanding of what it means to be a conscious being in an infinite universe. The questions will remain beautifully unanswered, ensuring that wonder stays fresh and curiosity remains eternally alive. And perhaps that's the most profound discovery of all. The universe has given us not the ability to travel faster than light, but something far more remarkable: the capacity to be conscious in a cosmos where such questions can be asked, contemplated, and lived with grace and wonder. Sleep well, fellow traveller, through the vast cosmos of possibility. May your dreams carry you on journeys that make the speed of light seem like a gentle stroll, and may you wake tomorrow with a renewed sense of wonder at the extraordinary fact that anything exists at all, including the remarkable consciousness that makes it possible to ask whether we might one day travel faster than light itself. The stars continue their ancient dance above, their light carrying messages across impossible distances, while in the even more mysterious realm of awareness, connections form instantaneously across every apparent boundary. Rest now in the knowledge that the greatest faster-than-light journey of all is already underway in the quiet space where consciousness meets the infinite mystery of its own nature. The soft rhythm of the universe's expansion echoes in your gentle breathing, carrying you home to the recognition that perhaps we were never meant to conquer the speed of light, but to discover that consciousness itself has always been the ultimate superluminal phenomenon, travelling at the speed of wonder through dimensions that no equation can fully describe and no spacecraft could ever reach. And so we arrive at the end of our gentle voyage through the cosmos of possibility, having drifted together through landscapes of thought more vast than any galaxy, more intricate than any quantum field. We've touched the edges of mysteries that have captivated human imagination since we first dared to dream of reaching beyond our earthly shores. The question that brought us together tonight, whether the laws of physics could ever allow faster-than-light travel, has revealed itself to be not just a scientific inquiry, but a mirror reflecting our deepest yearnings to transcend limitation, to connect across impossible distances, to find our place in a universe that stretches beyond every horizon we can imagine. We've discovered that the cosmos is far more generous with its possibilities than we ever suspected. From the elegant curves of space-time that might be surfed by exotic drives, to the quantum tunnels that connect distant points through dimensions we can barely conceive, the universe seems almost eager to offer pathways beyond the apparent barrier of light speed. Each theoretical framework we've explored, whether built from conventional matter or exotic energies, whether operating through technological marvels or the mysterious depths of consciousness itself, whispers the same tantalizing message. Perhaps the impossible is simply the not yet understood. But as the night deepens around us, and your breathing settles into the slower rhythms of approaching rest, we find ourselves face to face with a truth more beautiful than any equation, more profound than any experimental result. The greatest faster-than-light journey isn't waiting to be invented in some future laboratory. It's happening right now, in this very moment, as your awareness expands to embrace concepts that stretch across cosmic distances, as your imagination carries you to worlds that exist beyond the reach of any telescope. You are already the ultimate superluminal traveller, equipped with faculties that make the speed of light seem pedestrian by comparison. In the time it takes a photon to travel from your eye to this screen, your consciousness can leap to distant galaxies, explore alternate histories, and commune with possibilities that exist in the quantum realm of pure potential. This capacity for transcendent experience, this natural ability to touch the infinite through the finite instrument of human awareness, might be the most remarkable phenomenon in all of existence. The soft darkness that surrounds you now isn't empty space waiting to be crossed, but a fertile void pregnant with infinite possibility. Each gentle breath connects you to the same cosmic rhythms that govern the expansion of space itself, the same fundamental processes that might one day carry us to distant worlds faster than light can travel. You are not separate from this cosmic dance, but intimately woven into its deepest patterns, a conscious note in the universe's eternal song of exploration and discovery. As sleep draws near and the boundaries between waking and dreaming begin to blur, remember that the journey toward faster-than-light travel has already begun in the most sacred space of all, the mysterious realm where consciousness meets cosmos, where wonder transforms limitation into possibility, where every question about the nature of reality becomes an invitation to explore the infinite mystery of existence itself. The research will continue in laboratories and theoretical studies, in the quiet contemplations of brilliant minds wrestling with the deepest puzzles of physics. New discoveries will emerge, new possibilities will unfold, new pathways toward the stars will reveal themselves to future generations of explorers. But the most important discovery has already been made here in the gentle space between your thoughts, in the recognition that consciousness itself might be the universe's most elegant solution to the challenge of faster-than-light travel. Rest now in this cosmic embrace, knowing that tomorrow's dawn will bring not just the return of sunlight, but the continuation of humanity's eternal quest to understand and transcend the apparent boundaries of the possible. Whether that quest leads to breakthrough technologies that reshape our relationship with space and time, or to deeper recognitions of consciousness as the ultimate superluminal phenomenon, the adventure itself has already transformed us. In the gentle transition between waking awareness and the boundless realm of dreams, you're crossing a threshold more profound than any wormhole, more elegant than any warp drive. Here in the soft borderland of sleep, the normal constraints of physics dissolve into something far more fundamental, the pure creativity of consciousness exploring its own infinite nature. The question of whether we might one day travel faster than light has led us not to a final answer, but to something infinitely more precious, a deeper appreciation of the mystery that surrounds and permeates every moment of existence. We've discovered that wonder itself might be the fastest thing in the universe, traveling instantaneously from mind to mind, from generation to generation, carrying with it the eternal human impulse to reach beyond every apparent limitation. As your thoughts settle like cosmic dust after the passage of some great celestial storm, as your breathing synchronizes with the quiet rhythms of the night, remember that you carry within you the same stardust that forms distant galaxies, the same quantum fields that might one day enable faster-than-light travel, the same consciousness that transforms mere matter into something capable of contemplating its own cosmic significance. The gentle current of sleep that draws you now toward dreams and infinite possibility is itself a form of faster-than-light travel, carrying awareness beyond the confines of space and time into realms where the impossible becomes natural, where distance dissolves into connection, where every boundary reveals itself to be an invitation to transcendence. Sleep well, fellow explorer of the cosmic frontier. Dream deeply of journeys that make the speed of light seem like the gentlest of evening strolls. And know that whether we ever build ships that surf the curves of space-time, or learn to project consciousness across galactic distances, we have already accomplished something extraordinary. We have dared to ask the question, to wonder at the mystery, to reach with finite minds toward infinite possibility. The stars above continue their ancient dance, patient witnesses to our brief moment of cosmic curiosity. But in the even vaster space of consciousness, other forms of light move at speeds that make their photons seem frozen in time. The light of understanding, the light of wonder, the light of connection that binds every aware moment to the infinite source from which all questions arise and to which all explorations ultimately return. Tomorrow the quest continues, but tonight rest in the perfect knowledge that you are already travelling faster than light through the most mysterious dimension of all, the space between heartbeats where consciousness touches eternity, where wonder transforms the impossible into the inevitable, where every dreaming mind becomes a vehicle for exploring the infinite mystery of what it means to be aware in a universe that never stops surprising us with its hidden depths and secret possibilities. The speed of light may be the universe's posted speed limit, but consciousness, it seems, has always possessed a cosmic license to exceed every boundary, to explore every possibility, to find meaning not in final destinations but in the eternal journey of awareness discovering its own unlimited nature. Good night, gentle traveller. May your dreams carry you faster than light itself to places no telescope will ever see, but which exist nonetheless in the infinite library of consciousness, where all stories are written, all questions find their answers, and all seekers eventually discover that they were never separate from what they sought.